is express 2250 as a product of its prime factors. 2250 as a product of its prime factors. I said you read the whole question first, you read it twice, then you start solving. So express 2250 as a product of its prime factors. What number must be multiplied to the number to make it a perfect cube? So solve the first part of the equation, which says express 2250 as a product of its prime factors. So this 2250, we want to express it as a product of its prime factors. So the prime, we are going to get the prime factors. We start with 2. 2 goes into 2 once, into 2 once, into 5 twice, remainder 1 into 10, 5 times. Now, if we take 2, we divide by this, it will get into 1125, but there will be a remainder. So therefore, we don't use 2 again. We look at the next possible prime factor, which is 3. So if we take 3, 3 goes into 11 3 times. Remainder 2. Into 22, 7 times, which is 21. Remainder 1. Into 15, 5 times. So it means that 3 can easily go into 1125 without a remainder. Then again, we look at 3 again from here. 3 goes into 3 once, into 7 twice, remainder 1, into 15 5 times. Then you look at 3 again. Can 3 go into 125? Yes, but there will be a remainder. So you don't take 3. So you go to 5. The next one easily is 5 because 4 also there is a remainder. So when you take 5, 5 goes into 125 into 12 2 times. Remainder 2 into 25 5 times. Then 5 again, 5 into 25 5 times. Then 5 again, 5 into 5 once. So our prime factors of 2250, we have 2 raised to power 1 times 3 raised to power 2 times 5 raised to power 3. These are the prime factors. You've solved the first part of this equation. Then the next part says, now what are these prime factors? A prime factor is a number that is divisible by itself and 1. A number that is divisible by itself and 1. Then the next question says, what number must be multiplied to the number to make it a perfect cube? For it to be a perfect cube, the powers of the prime factors must be divisible by 3. For it to be a prime factor, to make a perfect cube, the powers of these prime factors must be divisible by 3. So far we are only seeing it is 5 that has power 3, which is divisible by 3. But 2 is raised to power 1. This is not the power is not divisible by 3. So therefore, you introduce part 2 of the equation. You introduce 2 raised to power 1. What number can you multiply by 2 raised to power 1 to make this power divisible by 3? That number is 2 raised to power 2. By the laws of indices, if you collect 2 and 2, you make 2, you take the base which is 2, then you add the powers. 1 plus 2 is 3. So this is 2 raised to power 3. So this power is divisible by 3. So therefore you've introduced 2 raised to power 2. Then you come to 3. 3 also, the power is not divisible by 3. So you make the power be divisible by 3. So 3 raised to power 2, you introduce 3 raised to power 1 so that it is divisible by 3. So this gives you 3 raised to power 3, which is divisible by 3. So you've introduced again 3 raised to power 1. So what we've introduced is 2 raised to power 2 and 3 raised to power 1. So those are the factors that you multiply. So you multiply 2 raised to power 2 times 3 raised to power 1. 2 raised to power 2 is 4 times 3 raised to power 1 is 3. So the answer is 12. I hope that is very clear. For you to make 2250 a perfect cube, what number must you introduce to make it a perfect cube? After getting the prime factors, which are these, you ensure that the powers of the prime factors are divisible by 3. So far only 5 has a power that is divisible by 3. But 2 has a power which is 1. So you introduce 2 times 2 raised to power 2 to make the power be divisible by 3. When you add the powers, you get 3. So what have you introduced? You've introduced 2 raised to power 2, which is 4. Then you come to the next number, 3 raised to power 2. What do you introduce? You introduce 3 raised to power 1. Then that 3 raised to power 1, you multiply by 2 raised to power 2. You get 12. So our answer is 12. Question 3. These are very common questions in exams. Now that question deals with prime factors. In the figure below, we are now dealing with angles, polygons, and plane figures as a topic. So in the figure below, let's draw the figure. We see what this figure is. This is the figure. That's our figure. In the figure below, GJ, this is our GJ. GJ is parallel. GJ is parallel to HI. And FH, where is FH? FH, this is parallel to this. And FH is parallel to CJ. To CJ. FH is parallel to CJ. Good. Angle AGB, this is B, this is a point B. A point A is here from our drawing, E, D, C. Good. Angle AGB is 30 degrees. AGB is 30 degrees. That angle is 30 degrees. Good. And angle AHC is 63 degrees. Find angle GCJ. Find angle GCJ. Now, angle GCJ, angle GCJ, this is the angle that we want. So I want you to be, let's name it angle X. So class, you are told that GJ is parallel to HI. What do you know about parallel lines? Now, parallel lines, if these angles are parallel, if these lines are parallel, then it means by extension, you can just do extension of this. By the first thing you do, just do an extension. Very good. You make an extension of this. Every time you're given such, make extension of these lines. Now, GJ is parallel to HI. There's a line in between here. There is that line. This angle you are told is 30 degrees. This is G. This is J. Then this is H. This is I. These two are parallel. If these two are parallel, This line is called a transversal line. Transversal line. Transversal line. If this line is a transversal line, it means that this, if this angle is 30 degrees, it means that this angle is also 30 degrees. Reason, you say they are alternate angles. They are alternate angles. So therefore, if this is 30 degrees, our angle here will be 30 degrees. And if this is 30 degrees and this is 63 degrees, angles in a triangle add up to 180 degrees. So angles in a triangle add up to 180 degrees. Therefore, angle Y is 63 plus 30 degrees. 63 plus 30 plus Y equals to 180 degrees. The reasoning is angles in a triangle add up to 180 degrees. So therefore, this is 93 degrees plus Y equals to 180. So Y equals to 180 degrees minus 93 degrees. Don't forget to write degrees. So angle Y equals to 180 minus 93, that is 87 degrees. So this angle is 87 degrees. If this angle is 87 degrees, this angle is also 87 degrees. What reason do you give? They are vertically opposite angles. Vertically opposite angles. Then again, you can get this angle Z, because angles in a straight line add up to 180 degrees. So angle Z is 93 degrees, is 180 minus 87 degrees, which is 93 degrees. But the question wants, find angle B, find angle GCJ. GCJ, this is what we want. Now, we also have FH is parallel to CJ. If FH is parallel to JC, and this is a transversal line, it means that if this is 63 degrees, then this angle here is also 63 degrees. Why? Because they are alternate angles. They are alternate angles. If this is 63 degrees, then by vertically opposite angles, this is also 63 degrees. If this is 63 degrees and this is 30 degrees and this is X, it means that angles in a straight line add up to 180 degrees. So therefore, angle X plus 30 degrees plus 63 degrees equals to 180 degrees. So X equals to 180 minus 93, which is 87 degrees. So this angle that we want is 87 degrees. So this is the angle that we want. We want angle GCJ, which is 87 degrees. So class, when you are solving angles, get to know the properties of these angles. Get to know what a transversal line is. Get to know what vertically opposite angles are. Get to know that angles in a straight line add up to 180 degrees. Angles in a triangle add up to 180 degrees. Then get to know the alternate angles. That is how you will solve such. There is no any other miracle in this. These are easy things, same principles. So that is our question 3. So our angle is 87 degrees. I was just trying to fill in these other angles. So for example, you can fill in here, which is 30 plus 87. 87 plus 30, which is 117. So this angle is 63 degrees. Why? It is also alternate to this. Then if this is 63, this angle is also 63 degrees. So that is how you fill these angles. This is alternate to this. So it's very easy for you to get these angles. And if this is 63, this is also 63. That is how you play around with it. We go to question number 4. So our angle GCJ equals to 87 degrees. Question number 4. angles again in a different way. In the figure below, AB is parallel to DE. So what's the figure? This is the figure. That is the figure. So you are told that A, B is parallel. AB or BA is parallel to DE. D is somewhere there. Then E is somewhere there. Then there is something interesting here. This is C. Then here you are told is 23 degrees. Then here you are told it is 70 degrees. This is our figure. So you are told, read the question in the figure below. AB is parallel to DE. Angle ABC is 70 degrees. And angle CDE is 23 degrees. Find angle. Our question wants angle BCD. Angle BCD. So before you do anything, just make extensions of these lines and this line. Make a complete extension. So the first rule that we have here, if this is 70 degrees, so angles in a straight line add up to 180 degrees. So this angle here is 110 degrees. And if this is 23 degrees and this line is parallel to this line, then therefore, if this is 23 degrees, this angle is also 23 degrees, which is alternate angles. Alternate angles. Then angles in a triangle add up to 180 degrees. So we can get this angle, which is 110 plus 23 degrees plus 23 degrees plus this angle X equals to 180 degrees. We name it angle X. So therefore, angle X degrees equals to 180 minus 133 degrees. 110 plus 23 is 133 degrees. So angle X degrees equals to 47 degrees. So this angle is 47 degrees. If this angle is 47 degrees, this angle will also be 47 degrees. You say it is vertically opposite angles. Now, if this angle is 47, what is this angle that we want? This angles in a straight line add up to 180 degrees. So, which is this angle? Angle BCD equals to, we call it Y, equals to 180 degrees minus 47 degrees, which is 133 degrees. So this angle will be 133 degrees. And now this point also is 133 degrees. Reason is vertically opposite angles. Then this angle, you mark where your D is so that we are not out. These angles are angles in a triangle, add up to 180 degrees. So we can get angle Z degrees, which is 23 degrees plus 47 degrees plus Z equals to 180 degrees. So Z equals to, this is 70, 110 degrees. So this angle is 110 degrees. Now, what is this angle? 70 degrees, because the angle is in a straight line. So this 70 is also alternate to this 70, because these are two parallel lines, and this is a transversal line. So the question wants angle BCD, which is 133 degrees. As simple as that. So these angles, these are things which you can't get. You can't afford to lose even a mark here. It is too expensive for us to lose a mark in a very cheap question. So we go to question 5. question 5. In the figure below, now these are different ways by which angles can be set. And I can assure you, class, these questions for angles are going to come. They are going to come. In the figure below, we draw the figure. PQRS is a rhombus. So we draw the figure. Don't mind my drawing. If it is not so beautiful, we will improve. So we have T, P, Q, R, S. My drawing might not be accurate, but get to listen what I'm explaining. In the figure below, P, Q, R, S is a rhombus. Up to that point, what do you know about a rhombus? A rhombus has all the sides equal. S, P, Q, R, all sides are equal. What do you know again about rhombus? In a rhombus, the opposite sides, S, P, and R, Q, are parallel. The two opposite sides are parallel. Again, PQ is also parallel to SR. The moment you do that, you've already deflated the energy of this question. You've already finished this. Very easier than eating yams. Now, angle SQR is 55 degrees. You are given here. Angle SQR is 55 degrees. Angle QS T is 90 degrees. 90 degrees. Is a right angle. Right angle means it's 90 degrees. And TPQ is a straight line. Good. Find the size of angle STQ. Size of angle STQ. Angle STQ. Angle STQ. This angle. This is what they want. This is the only thing you've been given. But you are also told that this is a rhombus. And you know they will not mark this for you. It is for you to find out that what is a rhombus. All the sides are equal. Then the two opposite sides are also parallel to each other. So this will help you, because now the moment you know that this is 55 degrees, this will also give you 55 degrees. Why? Because this and this side are the same, and this is a triangle. This triangle is called, a triangle whose two sides are equal is called plus. A triangle whose two sides are equal is called an isosceles triangle. The two sides are equal. A triangle whose three sides are equal is called an equilateral triangle. So this is an isosceles triangle. So if this is 55, this is 55, you can easily get this because angles in a triangle add up to 180 degrees. So it becomes 55 degrees plus 55 degrees plus, let's say this is angle at R degrees, equals to 180 degrees. Therefore, angle R equals to 180 minus 55 plus 55 is 110 degrees, which is 70 degrees. So this is 70 degrees. Then, if this is 55, because this is a parallel line and this is a parallel line, so this is a transversal line. So therefore, this angle is also 55 degrees because it's an alternate. It is alternate angles, 55. So therefore, if this is 55, this will also be 55. Why am I saying so? Because this line is parallel to this line and this is a transversal line. So this is alternate to this. If this is 55 and the whole of this is 90, so what is this angle Y? is 90 minus 55, which gives you 35 degrees. Very, very good. Now, if this is 55 and this is 55, what angle is this? Because this is an isosceles triangle. 55, 55, that is 110. Then 110, 180 minus 110 is 70 degrees. And if this is 70, what is this angle? Is 180 minus 70, which is 110 degrees. Angles in a straight line add up to 180 degrees. Now, this is the angle that we want, angle T. Then we have a triangle here. So, angle 35 degrees plus 110 degrees plus angle T equals to 180 degrees. Angles in a triangle add up to 180 degrees. So, T equals to 180 minus 35 plus 110 is 145 degrees. So, angle T degrees, which is equals to angle STQ, equals to 180 minus 45 degrees is 35 degrees. That's it. So get to know, I brought these 3 different types of angles. There are different ways of setting these questions for angles, but just get to know the principles. That is the only thing you need to know. Question 6, very easy one. It is about LCM and GCD. Now, you can either be given direct question or an application for LCM and GCD. I've also given you an assignment for application for this. So calculate the GCD, greatest common divisor, and LCM of 16 and 18. That is part A. So for 16 and 18 is simple. You write 16, 18. Let's start with the GCD. You use 2 prime factors. 2 goes into 16 8 times. 2 goes into 18 9 times. So the GCD, now, if you get another factor here, which is 2, it goes to 8, yes, but it goes to 9 with a remainder 1. If you get 3, 3 goes to 8 2 times, which is 6, remainder 2. So there's a remainder for 3, but it goes to 9 3 times. So if you are finding a GCD, make sure that you leave it at the point where the next factor can give you a remainder. So if the next factor gives you a remainder in either of these numbers, you leave it at that point. So our answer is 2. So GCD of 16 and 18 equals to 2. What about their LCM? Now, you leave it at that. Now, what about LCM of 16 and 18? You start with 2. When you are dealing with LCM, you ensure that that number divides all these factors. All the prime factors that you will use must finish with 1. It must finish dividing this with 1. So 2 goes into 16 8 times, goes into 18 9 times. 2 again. Remember, we want the least common, not the greatest. The greatest is a GCD, that's why we stopped at this. But the least, you go up to the least number. So 2 goes into 8 4 times. You drop 9 down. Then 2. 2 goes into 4 twice. You drop 9 down. Then 2. 2 goes into 2 once. You drop 9 down. The moment you remain with 1 here, now 2 can go into 9, but there'll be a remainder, so you avoid it. You go to the next number, which is 3. 3, this one is still 1. 3 goes into 9 3 times. Can we still lose another number? Yes, 3. 3 goes into, this one is 1 again. 3 goes into 3 once. So the factors that we have here are 2 raised to power 1, 2, 3, 4 times 3 raised to power 2. This is the LCM. You leave it in this form, or you can just simplify it, which is simply 16 times 9. 2 raised to power 4 is 16. 3 raised to power 2 is 9. 16 times 9 is 144. 14, 5, 144. So it can be, you leave it in this form or you write it as 144. Both are correct. That is part A of this question. Part B of this question, let's just go to the next page. Part B of this question tells you find the LCM, the GCD and LCM of 48 and 30. Now, in finding the GCD, we start GCD of 30 and 48. We take the list number first of all is 2. 2 goes into 30, 15 times. 2 goes into 48, 24 times. Now, is there any other number that can go to these 2 without a remainder? Yes. Is it 2? No, there will be a remainder here. Is it 3? Yes. So 3 will go into 15 5 times, but into 24 8 times. So any other number that can go into these 2 without a remainder? No. So we leave it at that. So the GCD is 2 times 3, which is 6. What about its LCM? Now, LCM, remember, we want of 30 and 48. We want the least common multiple. We start with 2. 2 goes into 30, 15 times. 2 goes into 48, 24 times. Can we use 2? Yes, because 2 can go into 24. Remember, we are dealing with the least. Because it can go to 15 with a remainder, we just drop 15 down. But can it go into 24? Yes. How many times? 12 times. Then we get another number, which is 2. Finish with 2 first. You drop 15. 2 goes into 12, 6 times. Again 2. Drop 15. 2 goes into 6, 3 times. Now, when you reach there, if you use 2, there will be a remainder. You go to the next number, which is 3. 3 goes into 15, 5 times. It goes into 3 once. Which number can we use again? 5. 5 goes into 5, 1, 1. In LCM, you ensure that this comes to 1, 1. So what is our LCM of this? LCM equals to 2 raised to power 1, 2, 3, 4. 2 raised to power 4 times 3 times 5. You can leave that answer in that form, or you can multiply. 2 raised to power 4 is 16 times 3 times 5 is 15. When you multiply these two, use a calculator. That is 8610. This is 240. Yes, Abu. Very easy. 240. So the LCM can be this or 240. That's finished. We go to question 7. Question number 7. 3 artisans and 2 craftsmen earn 220 shillings in a day, while 4 artisans and 1 craftsman earn 185 shillings in a day. Find the amount of money a craftsman earns in a day. Read the question again, and as you write, 3 artisans. This is an application for a simultaneous equation. So what they are testing here is a topic called simultaneous equation. So you write 3 artisans, 3A, and means plus 2 craftsmen, earns how much? 220 shillings. The next one, in a day. While 4 artisans, 4A, and 1 craftsman earns how much in a day? 185 shillings. Find the amount of money a craftsman earns in a day. How much does a craftsman earn in a day? The whole of that story has been reduced into this. Just by writing this alone, you have a 1 mark. Then now you solve it. How do you solve it? This is a simultaneous equation. You can use different methods if it is not stated. Number 1, yesterday we used a method called the matrix method to solve a simultaneous equation. You can use elimination method to solve the matrix question, to solve the simultaneous equation. You can use substitution method to solve it, and you can use graphical method, 4 methods. But this is a simple one. So, because we want the value of C, one craftsman earns how much? So, therefore, we will use elimination method. We want to eliminate A. So, 3A plus 2C, si ile elimination ya gava ile ya kuabduct na kuua. Hii ni another elimination. 4A plus 1C equals to 185. Now, by using elimination method, you multiply the upper one by 4 and the downer one by 3, because we want to make A the same. We want to eliminate A so that when we subtract, we get 0. So, if we multiply up by 4 and down by 3, then this is going to be 12A plus 4 times 2, 8C equals to 4 times 2, 20 is 80. Then the down one is also 12A plus 3 times 1C is 3C equals to 185 times 3 is 555. 555 if you multiply this. Then what do we do here? We subtract. When you subtract this, you get 0. When you subtract 12A minus 12A is 0. Then 8C minus 3C is 5C. Then 880 minus 555, what do you get? 523. 325. So for you to get the value of C is 5C equals to 325, divide by 5, divide by 5. So the value of C, 5 goes here once, 5 goes here, 6, remainder 2 into 25, 5 times. So you get 65. So each craftsman C earns 65 shillings. 65 shillings. Hiyo ni kidogo. Hiyo ni uchumi ya Kasongo. Craftsman anatoka tu na 65 bob. Hatari. So that is 65 shillings. That's all. If they wanted the amount of money that each is earning, then you substitute 65. Where the C is, you write 65, then you get the value of A. So let's see. Our answer is 65. But what if we wanted to know the amount of money earned by this person is called an artisan? So it is 4A plus C, which is 65, equals to 185. This is called substitution. You substitute. So this is 4A equals to 185 minus 65 is 120. So A will be equal to 30 shillings. 30 shillings. So that's all. So this question was so bulky, but class, this question was just testing simultaneous equation. So read the question and understand it. Read it twice. Then question number 8. It states, 3 years ago, Juma was 3 times as old as Ali. And I told you the way we got these questions, by the way, these are very common questions in examinations. Very, very common. Because I was sampling questions from 1989 to 2024, last year. And these are very common questions. So, 3 years ago, Juma was 3 times as old as Ali. In 2 years' time, the sum of their ages will be 62. What are their present ages? So, 3 years ago, just write Juma, then write Ali. Then, take your mind to 3 years ago. Do not take your mind, don't bring it here now. Just take your mind to 3 years ago. So, they tell you 3 years ago, be at 3 years ago, Juma was 3 times as old as Ali. If Ali was X, then Juma was 3X. This is 3 years. ago. If that was 3 years ago, now bring their ages to today. So now, let me call it now. Juma will be 3x plus 3 because that was 3 years. Now you bring it now, 3x plus 3. While Ali will be x plus 3. That is now. So tumetoka 3 years, tumekuja now. Then again, you are told that in 2 years' time, the sum of their ages will be 62. In 2 years' time. So go to 2 years' time. If now they are this, in 2 years' time, there will be 3x plus 3 plus 2. This will be x plus 3, Ali, plus 2. When you add the sum of their ages, it will be 62. Let me just remove here to be neat. Let's leave it at that. So you come to the next. The sum of their ages, which is 3x plus 3 plus 2 plus x plus 3 plus 2 equals to 62. Collect the like terms. 3x plus x is 4x. Then 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 2 is 10. Plus 10 equals to 62. So 4x equals to 62 minus 10. When 10 crosses the other side becomes minus. 4x over 4 equals to 52 over 4. So when you solve this, x is 16 years. So the question says, what are their present ages? Present, where is present? Now, here. So in 3 years ago, Ali was 16 years. You come here, Juma, Ali. So 3 years ago, class, 3 years ago, Ali was 16. But Juma was 3 times, which is 48. Then you come to now. Now, this person was 3x plus 3, Juma, while Ali was x plus 3. But what is our value for x? Is 16 plus 3. Here also 16 plus 3. So this is 48 plus 3 is 51 years. And this is 16 plus 3 is 19 years. So this is 13. X is 13, not 16. Class, be attentive and be very careful when you are solving this, because we have already gotten a very good answer here. Is 13, not 16. 13 years. So you replace here with 13, not 16. Here also 13. So this changes, becomes 16 years. So this changes, becomes 39 plus this is 42 years. So class, some of these mistakes can really cost you. And you see, even me, having known this is going to be 13, this is going to be 39. So even here, you might know the question, you might know how to solve it. But in the course of division, you mess, because 4 goes into 5 once. Remainder 1 into 12 3 times. So this is 13, not 16. So this is very correct now. So their present ages, Ali is 16 years and Juma is 42 years. Question 9. Three businessmen, Tumaini, Abu, and Sifuna, contributed a total amount of 120,000 to start a business. The ratio of their contributions of Tumaini to Abu was 2 to 3, and that of Abu to Sifuna was 2 to 5. How much did Sifuna contribute? So 3 businessmen, just write down Tumaini, Abu, and Sifuna. Contributed a total of 120,000 shillings. The ratio of the contributions of Tumaini, the ratio, this is under rates, ratios, proportions, and it comes together with percentages. So, the ratio of their contributions of Tumaini to Abu was 2 to 3. And that of Abu to Sifuna was 2 to 5. How much did Sifuna contribute? So we have the ratio of Tumaini to Abu is 2 to 3, and Abu to Sifuna is 2 to 5. But they all contributed 120,000. Now, the first thing that you do when you are given such is to harmonize the ratio for Abu, because Abu here has 3, and Abu here has 2. So we want to know a common ratio for Abu. So how do you harmonize? T to A is 2 to 3, Tumaini, then Abu to Sifuna is 2 to 5. So how do you harmonize this ratio? By multiplying, because the only common person here is Abu. So you multiply this side by 3 and you multiply this side by 2. Okay? Then you open it. This is 4 ratio 6 to 6 ratio 15. So therefore, you have a clear ratio here of Tumaini to Abu to Sifuna, which is 4 to 6. Now you see this is harmonized to 15. This, they contributed a total of 120,000 shillings. So therefore, when you have this ratio and you have this amount, you just get the total ratio here, which is equal to 120. So the total ratio here is 4 plus 6 is 10, plus 15 is 25. So that ratio 25, so Sifuna contributed 15 over 25. 15 over the total ratio, which is 25, times 120,000. This is Sifuna. While Abu contributed 6 over 25 times 120,000. While Tumaini contributed 4 over 25 times 120,000. Now, when you simplify this, you get 5 here 3, 5 here 5, 5 here 1s, 5 here 24. 3 times 24, that is 72,000. So Sifuna contributed 72,000. What about here? 5 here, 5. 5 into 120, 24. Then 5 here once. 5 into 240. Let me do some rough work. You just use a calculator. This is a simple thing. This is 48. 4, 8. Then times 6. This is 48, carry 4, 24, 28. So this person contributed 28, 800. And what about the last person? 5 here 5, 5 here 24. So that is 48 times 4. That is 32, carry 3, 16, 19, 19,200. So these are their contributions. So what does the question want? Sifuna's contribution, which is 72,000. Just that, class. Then we go to the next question. This is under measurements: length, area, volume, surface area, mass, density, and time. A base of an open rectangular tank is 3.2 meters by 2.8 meters. Its height is 2.4 meters. It contains water to a depth of 1.8 meters. Calculate the surface area inside the tank that is not in contact with water. Class, be very keen with such questions. They want the surface area inside the tank that is not in contact with water. So you're told that a base of a rectangular tank. So just draw a rectangular tank. We can do that. That's a rectangular tank. So this tank, you are told it is 3.2 meters length by 2.8 meters width. Then you are told that the height of this tank is 2.4 meters. It contains water to a depth of 1.8 meters. So let me change the pen. 1.8. I want red. So it contains up to 1.8 meters. So the water, if this is 24, the length, the height, then it contains water up to that level. So this is water. So this level that is containing water is 1.8 meters, which means that 2.4 minus 1.8 is 0.6. So this height that does not contain water is 0.6. So calculate the area that is not in contact with water, the area that is not in contact with water. The best thing to do is to draw the part that is not in contact with water with 0.6 meters as the height. So we draw a new rectangular tank. Very good. This is 3.2 meters. This is 2.8 meters. But the one that is not in contact with water is 0.6 meters. So they want you to find the area that is not in contact with water. So this is the new rectangular tank that we have that is not in contact with water, the upper part. So it's simple. You get the area that is not in contact with the water, which is 3.2 by 2.8. First is 3.2 by 2.8, but it is times 2. It is this side and the other side. This side and the other side. So it is times 2. Then you get this side, which is 3.8 by 0.6. This is 3.2 by 0.6. 3.2 by 0.6. Sorry, class. It is 3.2 by 0.6 times 2. Then 2.8 by 0.6 times 2, this other side. So 2.8 by 0.6 times 2. That's all. That's all you need. So when we open this up, we just want to do multiplication, but you can use your calculator. So when we open this, it is 32 times 12. 32 times 12. That is 432, sorry, 44623. You add 483. Then how many decimals? 1, 2. So this is 3.84 meters squared because it is area. Then what about this? This is 28 by 12. Then we 28 by 12. That is 6582. 633. 16582. Just use your calculator. I don't have a calculator here, so I'm trying to do this, or I'll use a phone. But to 2 decimal places, that is 3.36. So this is 3.36 meter squared. Then you add the 2, you get 0 carry 1, 2 carry 1, 7.2 meter squared. So this is the area that is not in contact with water. What about if the question wanted the area that is in contact with water? The area that is in contact with water, you could have used 1.8. 1.8, but this time round, you use 3.2 times 1.8 times 2 plus 2.8 times 1.8 times 2 plus 3.2 times 2.8. I hope I'm very clear. This will give you 3 parts. The area that is because the bottom is also in contact with water. Very good. The question can also tell you if this tank was full, which is the area that is in contact with water, full and closed. Full and closed. So therefore, you could have done 3.2 times the total height, which is touching water, in this case is 2.4, times 2, plus 2.8 times 2.4 times 2, because it is this side and this side and the other side. Then the base, 3.2 times 2.8 times 2, if it is closed. So this question can be set in those 3 different ways. Very good. So we go to question 11. We are almost through. Just be patient. Just 6 more questions. So in the next few, we'll be done. The solid shown in the figure below consists of a cylinder and a hemisphere of equal diameters of 14 centimeters. If the height of the solid is 22 centimeters, find its volume. So what is the solid that we have? We have a cylinder. We have a cylinder. And this cylinder has a hemisphere. Drawing yangu is not very nice, but it's okay. So you are told that the diameter here is 14 centimeters. Diameter is 14, which means that the radius is 7. This side is also 7. So if the radius from here to here is 7, it means that the radius of this hemisphere is also 7 centimeters. This upper part is a hemisphere. Hemisphere is hemisphere. Hemi is half. Half of a sphere. Then you are told that the total height here is 22 centimeters. But we know from here to here, you've already been told it is 7 centimeters. Because from here to here is the radius. You have not been told, but you just know the radius of this cylinder is 7. Therefore, from here to here is also 7. So the remaining length from here to here is 22 minus 7, which is 15 centimeters. Class, I think you are getting me. So the question wants you, if the height of the solid is 22, find its volume. Find its volume. Find its volume. So we have 2 figures here. We have a hemisphere, and then equally we have a cylinder. So we want to find the volume of a cylinder, and then we add to the volume of a hemisphere. Now, the volume of a cylinder is given by pi r squared h, normal. This comes to 22 over 7 times which is pi, times radius. If diameter is 14, radius is 7 times height. Height of this cylinder is 15 centimeters. So what do you get here? 7 with 7 goes. 22 times 7 times 15. So use your calculator, please. 22 times 7 times 15. Let me see if I can, this is 154 times 15. Use your calculator. That's what I'm getting. I don't know if we are correct. It's 2310. So just use your calculator isikupatie pressure. This is 2310, but volume is given by into centimeters cubed. That is the volume of a cylinder. Then now we have the volume of a hemisphere. But the volume of a sphere is given by 4/3 pi r cubed. But we are dealing with a hemisphere. So therefore, volume of hemisphere is half 4/3 pi r cubed divided by 2. This comes to 2/3 pi r cubed. So therefore, you come and solve the volume of this hemisphere, which is 2/3 times pi, 22/7, times radius cubed. If radius is 7, it is 7 times 7 times 7. When we solve this, you get 7 and 7. You get 44 times 49 divided by 3. 49 times 44. 36, 19, 36, 19. 6, 5. I hope I'm correct. 36, 6 carry 3, 16, 19. 6 carry 3, 19. 6, 15 carry 1. 10, 11 carry 1. 21, 56. Then you divide this by 3. So if you divide this by 3, what do you get? 2156 divided by 3. 3 goes here. 7. 7 goes here once. Remainder 2 into 26. 8 times. Remainder 2, which is 24 into 26, 6, 7. 718.67 centimeters squared, or cubed, because it is a volume. Squared is an area. So therefore, the total volume of this figure is the volume of the cylinder plus volume of the hemisphere, which is 2,310 plus 718.67 centimeters cubed. What do you get here? 2310 plus 718.67. You will help me use a calculator. I'm just doing this. You get 3028.67 centimeters cubed. 3028.67 centimeters cubed. Now this is the volume of our figure here. So class, the only formulas you need to master is volume of a cylinder, which is given by pi r squared h, volume of a sphere, which is given by 4/3 pi r cubed. But volume of a hemisphere is half the sphere, which is 2/3 pi r cubed. Now another commonly set question here, it is not part of our question, but I think it is in the assignments if I'm not wrong. This figure is called a frustrum. Frustrum. This is the diameter, this is the radius. So how do you get the volume of a frustrum? This one is also common. Volume of a frustrum, you are going to make it appear. This is a cone. This is a cone. You complete it. So you get the volume of the larger cone minus the volume of the smaller cone. You will remain with the first term. So volume of a cone is given by a third pi r squared pi r squared h. Is it? A third pi r squared h. That is the volume of a cone, where height is from here to here. This is the height. So this first term can also always come. So you just complete the cone, you get the volume of the whole cone minus the volume of the smaller cone, which is a third pi r squared h. Next question. We're almost through, so just be patient a little bit. Next question is on time. Mapesa traveled by train from Butere to Nairobi. Gari la Moshi. The train left Butere on Sunday. So from Butere to Nairobi. So the train left Butere a day like today on a Sunday. But it left at what time? At 23:50 hours. And traveled for 7 hours 15 minutes to reach Nakuru. After 45 minutes stop in Nakuru, the train took 5 hours 40 minutes to reach Nairobi. Find the time in the 24 hours clock system and the day Mapesa arrived in Nairobi. So this train left Butere. Mapesa left Butere going to Nairobi, but stopped at Nakuru. So he left at 23:50 hours. We want to know the time that he left. In 12-hour system, you subtract 23:50 minus 12:00. Sorry. You get 1:50. You get 11:50 p.m. Sorry. Now, this person left at night, 10 minutes to midnight. So he left on a Sunday, 11:50 p.m., which is only 10 minutes to Monday. 12:01 will be a Monday. So focus your mind. You change it first to 12-hour system. You get 11:50 p.m. So at 11:50 when he left, he traveled for 7 hours 15 minutes to Nakuru. He traveled for 7 hours 15 minutes. Just add what he traveled, that the time that he took to travel. You will get 5, 6. This is 65 minutes. 65 minutes, you can write there 0, you carry 1. You carry 1 hour so that you deal with minutes on their own and hours on their own. So it is 65. So here is 0, carry 1. This is 8, 9. This is 9, 1. So this person reached Nakuru at 19:05. But you remember, he left almost close to midnight. So when he took 7 hours, that is morning hours. So again, you change this into 12-hour system. You'll get 7:05 a.m. This is on a Monday. We are now on a Monday. Then is in Nakuru at 7:05 a.m. on Monday in the morning. Then you are told after 45 minutes stop in Nakuru. So it took 45 minutes stop in Nakuru. You add. You get 7:50. So by 7:50 a.m., he was still in Nakuru. Then the train took 5 hours 40 minutes to reach Nairobi. The train took 5 hours 40 minutes to reach Nairobi. You add again. This is 0. 5 plus 4 is 9. So that is 90 minutes. 90 minutes is 1 hour, 30 minutes. So you only put 30, you carry 1. This is 13. 7 plus 5 plus 1 is 13. So this person reached Nairobi at 13:30 hours. 13:30 hours, in 12 hours, you subtract 12, which is 1:30 p.m. but on a Monday. Hizi vitu ni kucheza tu na akili hapa na pale, but very easy things. Very good. We are almost through. We are coming to what we call trigonometry. 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 Now, on 24-hour, if you are leaving your answer in 24-hour system, then there is no decimal. You just write in 24-hour system, it is 13:30. But in 12-hour system is 1:30. There is decimal. So be very careful with that. So you can also be told to leave your answer in 24-hour system. But here, they want us to leave it in 12-hour system. Now, trigonometry question 13. Given that sine, this is called sine, not sin, sine x plus 60 degrees equals to cos 2x degrees. Find tan x plus 50 degrees. Class, I want to explore the different ways by which this can be set, and I want to deal with this to detail so that any question that comes on trigonometry, you will automatically score it. Sine x plus 60 equals to cos 2x. Find tan x plus 50. Now, number one rule, we are going to do the identity triangles. Identity triangles. We have the rules for the trigonometry, and the rules, the first rule is always cos squared theta plus sine squared theta equals to 1. This is a rule, but we are not going to apply it here. I'm just giving you everything that can come in this and how you will make the application for all this. Then we also have another rule that states that sine theta over cos theta equals to tan theta. This is also another rule. But when we come to this, I want us to deal with the identity triangles in trigonometry. Then I will come and solve this. So let us work out the identity triangles that we have. Then I come and solve this. So the first identity triangle is this. This is a right angle triangle. If this is theta, this is right angle, this is 90 minus theta degrees. Second identity triangle is this. Oh, sorry. This is 90. My drawing is inakaa vitu zake, but is okay. This is 45 degrees. This angle is also 45 degrees. This is 1, 1. If you want to get hypotenuse, is height squared plus length squared into the square root, which is root 2. Now, the third identity triangle, let me put it here. The third identity triangle is this, is an equilateral triangle. And then you divide here. If you divide here, this is 60 degrees, 60 degrees. Then this is also 60 degrees. This comes to 30 degrees, and this is 30 degrees. Now, this is 2, 2, 1, 1. What is the height? Hypotenuse squared, which is 4 square, which is 2 squared, which is 4, minus 1 squared into the square root. So this is root 3. Now from here, class, I want us to list down the tan 45, sine 45, cos 45. Then we go to sine 30, cos 30, tan 30, sine 60, cos, like that, like that. So when you come here, you say, we start from here, sine 45 degrees equals to, the common principle that we use here is SOHCAHTOA. We are on this triangle for 45 degrees. So sine 45 equals to opposite. This is the opposite, adjacent, hypotenuse. So we go to opposite, which is 1, over hypotenuse, which is root 2. Now sine 45 is 1 over root 2. When you open this in surd form, this is a surd, you rationalize, will be root 2 over 2. This is root 2. Root 2 times root 2 is root 4. Root 4 is 2. So sine 45 is root 2 over 2. Then you go to cos 45 degrees. Cos 45 is adjacent, which is 1, over hypotenuse, which is root 2. Again, you rationalized by root 2, which is root 2 over 2. So you realize that sine 45 equals to cos 45. Therefore, these two angles, 45 plus 45, equals to 90 degrees. We will use it in our equation. Let's just go on first. Then tan 45 degrees equals to adjacent over, is equal to opposite over adjacent. So tan 45 equals to 1. Then you come to this other identity triangle, where we have SOHCAHTOA still, but we want to get sine 30. Sine 30 equals to opposite, which is 1. You take this triangle we are here, sine 30 equals to opposite, which is 1, over hypotenuse, which is 2, half, which is 0.5. Then we go to cos 60. Cos 60 equals to adjacent, which is 1, over hypotenuse, which is still half. So you realize that sine 30 equals to cos 60. Therefore, 30 degrees, these are in degrees, 30 degrees plus 60 degrees equals to 90. We will come back and solve this. Then you go to tan. Tan 30 degrees equals to opposite over adjacent, which is 1 over root 3. If you rationalize this, you get root 3 over 3. Very good. Then we go to sine 60 now. We've done sine 30, so we go to sine 60 degrees. So sine 60 degrees equals to opposite, which is root 3, over hypotenuse, which is root 3. Root 3 is 1.7321. Then we go to cos 30. Cos 30 equals to adjacent, which is root 3, over hypotenuse, which is root 3 over 2. My sine 30 equals to opposite over hypotenuse, root 3 over 2. Sorry, class. This is root 3 over 2. Sine 60 equals to opposite over hypotenuse. Then cos 30 equals to adjacent over hypotenuse. So cos 30 is equal to sine 60. Sine 30 equals to cos 30. So there's a similarity into this. What about tan 30? Tan 30 we said is adjacent, is opposite over adjacent, 1 over root 3, which is 3, root 3 over 3. So this is what we have. Then tan 60. Tan 60 equals to opposite, which is root 3, over adjacent, which is 1, which is root 3. So class, when you have this for your identity triangles, you can solve any trigonometric equation plus these 2. So I want you to be careful here. Now, what does our question say? Our question says sine x plus 60, sine x plus 60 degrees equals to cos 2x degrees. Then we are told to find tan x plus 50 degrees. So class, you saw the relationship between sine and cosine. We said sine 30 equals to cos 60, or cos 30 equals to sine 60. So there's 30, there's 60, that is 90, which means that these angles, when you add them, equals to 90 degrees. So when you take x plus 60 degrees plus 2x, these angles equals to 90 degrees. When you take these two angles, equals to 90 degrees. Therefore, this is 3x degrees equals to 30 degrees, 90 minus 60. So solve for x equals to 10 degrees. So if x is 10, just come and replace 10 here. So they want us to solve tan x, which is 10 plus 50. So they want us to solve tan 60 degrees. Tan 60 degrees, from our identity triangle, tan 60 degrees is root 3 here. So tan 60 degrees, if you draw this triangle, this is 60 degrees, this is root 3, 2, 1. This is 30 degrees. So SOHCAHTOA. So tan 60 degrees equals to opposite, which is root 3, over adjacent, which is 1. So the answer we have is root 3, which is equal to 1.7321. If you get the square root of root 3, I think you will get that. Use your calculator, but you can leave it in this form. So we have solved that question. We are almost through question 14. Don't leave class. Usiogope. Usitoke class. Now, before I go there, there's also a very commonly set. I want to still take you through this trigonometry. All students take coffee. This is 0, 90 degrees, 180 degrees, 270 degrees, and again 360 degrees. So class, you can be told to find sine 60 or sine 30. It falls in the first quadrant. This is all. In this first quadrant, sine is positive, tan is positive, cosine is positive. In this second quadrant, only sine is positive, but tan and cosine are negative. What am I saying? If you are told to, this is 0 to 90, then 90 to 180. If you are told to find sine 150 degrees, sine 150 degrees, you draw this quadrant. In this quadrant, sine is positive. So sine 150 will be sine of 180 minus 50 degrees, which is equal to sine 30 degrees. But if you are told to find tan 150 degrees, tan 150 degrees, yes, you will do tan of 30, tan of 180 minus 150 degrees, which is tan of 30 degrees. But it will be the answer that you get, you multiply by -1, because it is negative. 150 lies here, falls here. So you first of all identify that degree, where does it land? Let's come here. In this quadrant, you are told to find tan to 30. Tan to 30 in this quadrant is positive. So it will be a positive answer, which is 270 to 40, tan to 40, which is 270 minus 240 is like the tan 30. But in this quadrant, if you are told to find sine 240 degrees, the answer that you get, which will be 270 minus 240, is the same as sine 30, but it will be negative. You multiply by a negative 1. So class, be very careful, because also this can be set. You only do this exam once. Also this can be set. So you wonder what will happen. So sine 240 is the same as negative sine 30 degrees. It is negative in this quadrant, which is 270 minus 240. If you come here, only cosine is positive. So if you are told 300 degrees, that get cos 300 degrees. So cos 300 degrees is the same as cos 60 degrees, which is 360 minus 300. But if you are told to find sine 300 degrees, will be negative. It is negative. Negative sine 60 degrees. So these large angles will help you to identify the sign that you use, because you might end up calculating but you get it wrong. So all students take coffee. All in the first quadrant, sine, tangent, and cosine are all positive. In the second quadrant, only sine is positive, but tan and cosine in this quadrant is negative. Here, only tan is positive, but negative. Cosine is negative here, sine is negative here. And here, only cosine is positive. I think that is well elaborated. Now, we go to question 14. Question 14, the angle of elevation. The angle of elevation, that is an application for trigonometry. The angle of elevation of the top of a cliff from a point P. So let's say our point P is here. So the angle of elevation of the top of a cliff, that angle, you are told, is 30 degrees. Then you are also told from a point Q, which is 10 meters from P. Point Q, 10 meters from P. So Q is somewhere there. 10 meters from P. You are told that the angle of elevation from this point, this angle, they say is 60 degrees. Calculate the height of the cliff. So which means that the cliff is dropping here. So this is the cliff and this is the height. So read the question again. The angle of elevation from a point P is 30 degrees. Angle of elevation is the worm's view, the worm looking at the bird. But the angle of depression is the bird's view looking at the worm to eat. Now, the angle of elevation from a point P is 30 degrees. You elevate, unaangalia the top of a cliff, is 30 degrees. Then you are told a point Q from P, 10 meters from P, if you stand here, if you look at the angle of elevation, is 60 degrees towards the base of the cliff, the foot of the cliff. Calculate the height of the cliff. Now, you have height, you have this adjacent. So from here, Q, to the foot of the cliff, let's say it is X. So class, when you look at this, just write SOHCAHTOA. So from SOHCAHTOA, we don't have hypotenuse, but we want height. And we have the adjacent. So what fits here? Sine does not fit, cosine does not fit, because these two has hypotenuse. But what fits here is now tan. So therefore, we say tan of 30, remember from P to Q is 10. Then from Q to foot, we put it as X. So therefore, from P to foot is x plus 10. So we say tan. So tan of 30 degrees equals to opposite, which is height that we want, over adjacent, which is 10 plus x. At the same time, tan of 60 degrees, this equals to opposite, which is h, height over adjacent, which is x. So we have these two. What do we want? H. Therefore, we want to make h the subject of the formula. So in this case, h here, h equals to 10 plus x tan 30, sorry, degrees. I've just cross multiplied. I cross multiply both sides by 10 plus x by 10 plus x. So I remain with h equals to 10 plus x tan 30. Then at the same time here, I cross multiply, I get h equals to x tan 60 degrees. But from our identity triangle, I'm drawing it here, from our identity triangle, if this is 60, this is 30, I already did it. This is root 3, this is 2, and this is 1. We said that tan of 30, we want tan of 30. Tan 30 from here, degrees, equals to opposite, which is 1, over adjacent, which is root 3. 1 over root 3, you rationalize because it is a surd, is 3 over 3. By multiplying the denominator by root 3, numerator by root 3. You will remain with root 3 over root 9, which is root 3 over 3. So from here, we have 10 plus x, follow me keenly, into root 3 over 3. Root 3 over 3. We've said root 3 over 3 is tan 30. So we want to equate this height to be equal to this height. Therefore, this equation is equal to this equation. So let me equate them first. H, so 10 plus x, forget this first. So 10 plus x tan 30 degrees equals to x tan 60 degrees. Therefore, 10 plus x, we've said tan 30 is root 3 over 3 equals to x tan 60. What is tan 60? Tan 60 is opposite over adjacent, which is just root 3. Class, let's observe this keenly. So tan 30 is opposite over adjacent, which is 1 over root 3 times root 3 times root 3. So root 3 over 3. Very good. So in solving this, we have what is common here is root 3 and root 3. So root 3 can cancel root 3. So here we have 10 plus x equals to root 3 cancels root 3. You remain with x, then cross multiply by 3 on both sides, equals to 3x when you solve this. So therefore 10 equals to 2x. When x crosses the other side becomes minus x. So x equals to 5. So if x is 5, what is h? You just come here, you replace, because that is what we want. We don't want this x, but it helps us to get h. So if x is 5, our h becomes 5 tan 60. So our h becomes 5, but tan 60, we've already gotten tan 60. Tan 60 is root 3. So this is our answer. In what? In meters. So when you further solve this, 5 times root 3. Root 3 is 1.7321 times 5. 5, 10, 15, 16, 35, 36 is 8.66 meters. And this thing's easy, very, very easy. So that is question 14. We are only remaining with 2 questions. So 2 questions, but very interesting ones. Question 15 is binomial expansion. Binomial expansion. Binomial expansion. So you are told expand in 2 plus x raised to power 5 in ascending power of x up to the term. Be careful about these terms. Term x cubed. Hence, approximate the value of 2.03 raised to power 5 to 4 significant figures. So this value, you are told to expand up to the term x cubed. But we have 2 plus x raised to power 5. So we are going to write a Pascal's triangle. Pascal's triangle is easy to construct. You start with 1 here, then 1 and 1. Then you go to 1. 1 plus 1, 2, 1. Then you go to 1. 1 plus 2, 3. 2 plus 1, 2. Then 1. Then another 1. There's another mathematician who was called Pascal. So Pascal is a serious mathematician who came up with this triangle. So the triangle, you start with 1, 1, 1. Then you do 1. Then you add 1 plus 1, you get 2. Then 1. Then you do another 1. 1 plus 2, 3. 2 plus 1, 3. So this is 3, not 2. Then you do another 1. Then you go to another 1. 1 plus 3, 4. You write just in between the spaces. Then 3 plus 3, 6. Then 3 plus 1, 4. Then another 1. Then you go to 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Then another 1. So, but because we have been restricted to this power, so these are the values that we are going to use on this Pascal's triangle. These are the values that we are going to use. So from here, we are going to use 1, 5, 10, 10, 5, 1. We are going to leave our Pascal's triangle there. So from here, you have 2 plus x. So just write 2, 2, 2, 2, 2, 2. Then you write the value of x. These are coefficients. X, x. These are coefficients. These are called coefficients. So you write x, 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 x. Then you simply add them. Products, add. So you will multiply this, you add to this. You multiply this, you add to this. You multiply this, you add, like that. So this 2, because we have power 5, this 2 starts from power 5 in a descending order. 5, 4, 3, 2, 1, 0. But x starts from 0 in an ascending order. Ascending order. That is 0, 1, 2, 3, 4, 5. So when you do this, you just simply multiply them. So when we multiply this, what do we get? 2 raised to power 5 is 32. But this is x raised to power 0, which is 1. Any number raised to power 0 is 1, we said yesterday. Plus, now 1 times 32 is 32. 2 raised to power 4 is 16. 16 times 5 is 80. X raised to power 1. 2 raised to power 3 is 8. 8 times 10 is 80. X raised to power 2. Just multiply this and then you add them, plus 2 raised to power 2 is 4 times 10 is 40 x cubed, plus 2 raised to 2 times 5 is 10 x raised to power 4, plus 1 times 1, 2 raised to power 0 is 1 times x raised to power 5 is x raised to power 5. But remember, we want up to the term where x cubed. So this is what we'll deal with. So our answer here is 32 plus 80x plus 80x squared plus 40x cubed. That is what the question wants to expand. This is the expanded form of this up to the term x is raised to power 3. Then an interesting part that is attached to it that we'll also not miss is after getting that, they tell you, so let me copy this here. Let me copy this here. 32 plus 80x plus 80x squared plus 40x cubed. The next part of this question tells you, hence, approximate the value of 2.03 raised to power 5. Remember, we had, our initial equation was 2 plus x raised to power 5. So we want to find the value of x, because 2 plus x raised to power 5 is the same as, is equal to 2.05. So you equate 2.03 raised to power 5 equals to 2 plus x raised to power 5. Because these are the same, these are equal. What is inside here is equal to what is inside here because the powers are also the same. So therefore, 2.03 equals to 2 plus x. Make x the subject of the formula. X equals to 2.03 minus 2. So x equals to 0.03. So in this expanded form equation of ours, this expanded form, you replace where there is x, you put 0.03. So you come back here, you do 32 plus 80 times 0.03 plus 80 times 0.03, where there is x, but it is squared, plus 40 times 0.03, but it is cubed. Now, this thing is very, very petty. So you have to use a calculator because you might lose the decimals. But because I don't have a calculator, I will just calculate it, so we will compare. So let's compare. Let's go. 32. This is still 32. Plus 80 times 0.03, which is 80 times 3 is 240. Then how many decimal places? 1, 2. 1, 2. So it is 2.40 plus 80 times 0.03 squared. So from here, 0.03 times 0.03 times 80. So this is 80 times 9 is 720. Then 1, 2, 3, 4. 4 decimal places. 1, 2, 3, 4. So the next one is 0.0720 plus the last one is 40 times 0.03 times 0.03 times 0.03. So we have 0.03 times 0.03 times 0.03 times 40. So this is 3 times 3 is 9 times 3, 27. 27 times 40 is 8 is 1080. 28 carry 2, 8, 10, 1080. Then how many decimals? 6. So 1, 2, 3, 4, 5, 6. So this is 0.001080. Then we add this. So when we add this, I want us to be neat. 32.0000. You add 2.40. You add 0.0720, you add 0.001080. 0.80374443. So our answer is 34.473080. But they want to 4 significant figures. 1, 2, 3, 4. This is less than 5, so this remains 7. So it is 34.47. Think we are correct? This will come. Then the last question, class. Then I give you assignment. Question 16. Now that last question, I did not type it there. But I've decided to put it now, just a few minutes before I started the lesson, because I also noticed that it is very common. It is about SADs. So I want you to write down the question. The question states, simplify by rationalizing the denominator of the expression. The expression is on the board here. Root 3 minus root 2 divided by root 3 plus root 2. Giving your answer in the form of A plus B root C, where A, B, and C are integers. I want to read the question again. The question: simplify by rationalizing the denominator of the expression. This is the expression, root 3 minus root 2 divided by root 3 plus root 2. Giving your answer in the form of A plus B root C, where A, B, C are integers. Now, class, when you see this, this is SADs. So when you are rationalizing, simplify by rationalizing the denominator. So when you have this, rewrite this, root 3 minus root 2 divided by root 3 plus root 2. Then when you simplify by rationalizing the denominator, means that you will multiply both the numerator and the denominator by the conjugate SAD. Conjugate SAD, I will explain. Conjugate SAD of the denominator. I repeat, when you are rationalizing or simplifying this SAD, you will multiply the numerator by the conjugate SAD of the denominator, and also the denominator by the conjugate SAD of the denominator. What does a conjugate SAD means? It means that the SAD of the denominator remains the same, you only change the sign. So you multiply the numerator by the same denominator, sign changed, and the denominator also by the same SAD, only the sign changed. So you multiply this by root 3, but instead of plus you write minus root 2. You also do the same by root 3 minus root 2. Class. So when you have this, you don't have to worry, just open it up slowly. The first value times this. So this will be root 3 times root 3 is root 9. Root 3 times root 3, just multiply what is inside, then maintain the root, is root 9. Good. Then root 3 times minus root 2 is minus root 6. Class. So 3 multiplies this, root 3 multiplies this, then root minus root 2 multiplies this. Then you come here. Then minus root 2 times root 3 is minus root 6. You just multiply what is inside, you retain. But you be careful about the signs. Then lastly, minus root 2 times minus root 2 is plus root 4. That is the numerator. What about the denominator? Root 3 times root 3 is root 9. Then root 3 times minus root 2 is minus root 6. Then root 2 plus root 2 times root 3 is plus root 6. Then plus root 2 times minus root 2 is minus root 4. From here, we simplify. Let's go up. The numerator, root 9 is 3. Minus. Now, minus root 6 minus root 6. If you're given minus root 6 minus root 6, what you do, you had the all numbers which are here. It is assumed or presumed that 1 is there. Because if it is 0, it makes the whole thing 0. So you only add minus 1 plus minus 1, which is minus 2. Then you maintain the same root. If it was 2 root 2, 2 root 3 plus 4 root 3, you only add this and this. You get 6, then you maintain the root. So you come here. This is minus root 6 minus root 6 is minus 2 root 6. So minus 2 root 6 plus root 4 is 2. This divide by, you come down, root 9 is 3. Then minus root 6 plus root 6 is the same as minus 2 plus 2. This is 0. So minus root 6 plus root 6 is 0. Minus root 4 is what? 2. Then simplify here further. 2, collect like terms. 3 plus 2 is 5. Then we have minus 2 root 6. Divide by 1. So our answer here is 5 minus 2 root 6. But you've been told that you're giving your answer in the form of A plus B root C. This is in that form, where A, B, and C are integers. So our A is what? 5. You can state them. Our B is minus 2. And our C is 6. So this is our answer. So once again, class, we are done with today's class. I want to take this opportunity to thank you very much for concentrating in class. For those who are sleeping in class, make sure you wake up next time. Make sure you do revision. For those who have not understood whatever we've taught, whatever we've revised, please revise again. Go to that friend of yours in your class who understands this better. Nobody was born knowing these things. I know. Do not feel ashamed. Do not have low self-esteem. Do not have low confidence that you don't know. Nobody was born knowing. Everybody went to school to acquire knowledge, and therefore go to your friend to help you. Friends, be kind with knowledge. That is when you can pass. Go to your teacher also. Disturb your teachers. Let them help you also. I wish you all the best in your exams, which will be starting next month, and I know that you are going to pass your examinations. There are assignments that I'm going to give. I will let them run for close to around 10 minutes. Make sure you do those assignments. There's a reason why I'm telling you so. I wish you all the best in your exams, which will start on the 3rd of November next month. Until we meet again, God bless you. Remember to put God first in everything that you do. Asanteni sana kwa wamama wangu na wababa wangu ambao pia wamepatia watoto wao masimu na makompyuta kuwatch hii lesson. Nataka kuwa wish all the best. Mama, baba, najua unaamka asubuhi kwenda kutafutia mtoto wako. Usichoke. Unamtafutia karo ya shule, unamtafutia kodi ya nyumba, na pia unajitafutia chakula. Usichoke, naye huyo mtoto wako ndiye siku moja atakuja kutoe kwenye matope. Huyo mtoto ndiye atakuja kutoe kwenye jua. Kwa bodaboda rider ambao ni mababa yetu, kwa wale mababa yetu wanaenda jua kali, wanaenda mjengo, usichoke. Tushikane, tusaidie watoto wetu waelimishwe, wasomeshwe, na hapo mbele najua tutavuna. Asanteni and God bless you. Thank you very much. Until we meet again. Success.